Okay, the following is a video over pre-calculus, Unit 2 notes. This is Section 1. We're talking about linear functions. And so we want to determine if a function is linear, and then we want to represent linear relationships either numerically, algebraically, or graphically. So the fundamental part of a linear function is the root word here that represents line. Okay, so each time you have a linear function, you have a line, okay? And so, every line has a specific, attributes to it. Mainly, you have a slope, and that represents your steepness. Okay, and you have some sort of y-intercept, x or y-intercept, or y-intercept, sorry, or y-intercept, okay? The most common one that you have, and you guys are all familiar with this because it's pre-calc, is you're pretty familiar with the concept of y equals mx plus b. Okay, this is a linear function, so this is a linear function, and it's called slope-intercept form. Okay, where m is your slope, and the b is your y-intercept. Okay, so we have this problem up here, y equals 2x plus 3. So when I have y equals 2x plus 3, and I'm going to rewrite this over here so we got some room, y equals 2x plus 3, then, this is of the form of y equals mx plus b. So our slope is the value of 2, it's the number in front of the x, and then our y-intercept is equal to 3. Okay, now here's the thing. Our slope being 2, that is I'm going to rewrite that as 2 over 1 because that's our rise over our run. Okay, and b equals 3, our y-intercept, this is our starting point. Okay, so what I do is if my y-intercept is 3, then I locate 3 on my graph over here. Okay. And I go up to that point and I mark a point at 3 on my y-intercept. Okay, then I use my slope and use rise over run to get the other points in that graph. So I'm going to go up 2 values and then over 1 and plot a point. So I've got a point right here. Okay, I can also go the other way and go down to the left 1 and plot a point there. Okay, and I can kind of keep doing that, and you get this linear relationship. And if you connect all those points together, then you get a line, okay, and you can graph that line. All right, so that's it. All right, so kind of a review. All right, we also have standard form of a linear equation, okay, and that's where you have this kind of standard form where ax plus by is equal to c. Okay, a, b, and c are real numbers, and such that a and b are not both 0. A is positive. Okay, all that crap. Basically, what this means is that, you've got x and y on both sides of the equal sign, okay? So x and y are on either the left or right side of the equal sign. When you had slope-intercept form, you had solved that equation for y, all right? That's the only difference, all right? So all I'm going to say for standard form is that both x and y are on the same side of the equal sign. Okay? So over here, okay, in this problem, you've got an equation in standard form. You've got x plus 2y is equal to 16. This is in standard form. The question is, it's asking us what's the slope of the line. It's hard for me to determine that. But if I were to solve this equation for y and put it into slope-intercept form, then I could get the slope. So let me rewrite this. I'm going to do x plus 2y is equal to 16. If I solve this equation for y, So I'm going to subtract x from both sides, and that's going to give me 2y is equal to negative x plus 16. And then I divide both sides by 2, and I divide everything by 2. So if we isolate y, and we're going to get that y is equal to, and I'm going to write this as negative x over 2 plus 8. All right, and this is in slope-intercept form, but we have, kind of a problem here, is that I can't really identify the number that's in front of the x. So I'm going to rewrite this up here. I'm going to write y equals negative x over 2 plus 8. And so this is a little bit tricky. Now, dividing, I want you guys to see something. If I divide by 2, that's the same thing as multiplying by a half, okay? I can rewrite this and say that this is y is equal to negative 1/2 times x plus 8. That's a crucial step, all right? That way, now I have this number that's in front of the x, and so my slope, m, is equal to negative 1/2. And that's the answer that I'm looking for, okay? When you do have a fraction like that, it is kind of hard, especially when you have this, but that's just something where we need to be able to go from this step to this step and understand that, okay? And if you're having trouble with that, then, come talk to me about it if we ever have issues, okay? The next one we have is what's called the point-slope form of a linear equation, okay? And so that's where you can write the equation of any line if you have a point, okay? This is a point, all right, is a point on the line, and m is your slope, okay? So, just here, you've got this value, or you've got this up here. If you were to identify this, you would say that your slope m is equal to 2. Okay, that's that value there. And then this is your x value here, and this is your y value there. So the point that you would have would be the point 1, 5. Okay. Now, if you also wanted to take this and put this into, say, slope-intercept form, okay, then what we would do here, let me rewrite this and say y minus 5 is equal to 2 times x minus 1. Now, what we would do, okay, to put this into slope-intercept form is we would multiply out the 2, okay, distribute the 2, so you get y minus 5 is equal to 2x minus 2. Add 5 to both sides, and so you get y is equal to 2x plus 3, okay? And this is in slope-intercept form. Now, here's the thing you guys need to realize is that this and this are the same thing, just written differently. And that's it, okay? All right, and then it says, on this one, the equation y minus 2 equals 3 times x plus 1 is in point-slope form, which is the slope-intercept form. So let's go ahead and do that real quick again. I've got y minus 2 is equal to 3 times x plus 1. If I distribute my 3, okay, I get y minus 2 is equal to 3x plus 3. And then I add the 2 to both sides, combine my like terms, and we end up getting that y is equal to 3x plus 5, okay? And that's my slope-intercept form. That's my answer, okay? All right, and then it says, on this bottom one, it says, which is the graph of y equals 5x plus 5? Okay, so you have to be able to take a look at these and go, okay, which one is which? What I notice about this is that this equation is in the form of y equals mx plus b, okay? Which means it's in slope-intercept form. So what I know is I know the slope, okay, m, and m is equal to 5, okay, in this case. And I also know my y-intercept, b. I know where the graph crosses the y-axis, okay? So this is really what's going to help me. And so if I look over here, I notice that this graph has a y-intercept of negative 2, okay? This graph looks like it has a y-intercept of 5, and this graph has a y-intercept of 1. Okay, because I know for a fact that I am looking for the y-intercept of 5, I automatically know that this is my answer. Okay, if there are other questions that you'll see that are kind of similar to this, but that's what I got for that one. Okay, the one thing I do want to talk about is that it's asking us in this, it says select all of the equations that represent linear relationships. Okay, the way I know that if a function is linear, so I'm going to write this, a function is linear if x and y or y have an exponent of 1. Okay? So what we notice here, that's all I'm looking for. Okay? And you don't have to always have you can have an x or just a y. You can have both. But, notice how the exponent, there is no exponent. You can just assume that the exponent is 1. Okay? Exponent is 1. All right? Exponent is 1. Exponent is 1. Exponent is 1. 1 and 1 and 1. The only one that doesn't have an exponent of 1 is this one. That has an exponent of 2. Okay, this is not linear. All right, so you have to have an exponent of 1 in order for a function to be linear. Any other value, then it's not linear. Okay, let's take a look at the next problem. The next problem shows us the scenario where we're selling movie tickets. Child tickets for the movie is $6 and adult tickets are $9. The total revenue is $1,500. And so we modeled this situation with this equation, 6x plus 9y is equal to $1,500, okay? First of all, let's say that x is the number of child tickets, okay? And let's say that y is equal to the number of adult tickets. Okay? And so what's asking us to do is says which graph shows this relationship here. Okay? So the way that I would want to do it would be to solve this equation for y. So I've got 6x plus 9y is equal to 1,500. If I subtract 6x from both sides, so minus 6x, then that's going to give us 9y is equal to negative 6x plus 1,500. Okay. If I divide each of these by 9, okay, I get y is equal to, now this fraction here simplifies to negative 2/3. So I'm going to do negative 2/3 x, and then plus, and then this fraction, if you divide out 1,500 divided by 9, it gives you 166.6 repeating. Okay, so all we're trying to do now is figure out which one of these graphs represents that situation. Now, what we notice is that all of the graphs have the same y-intercept. The question is which one of these has a which one has a slope of negative 2/3? Okay, so down to over 3 is the question. So there's a couple of ways to do that, but the way that I'm going to do it is to figure out what is our x-intercept. Okay, and so to figure out our x-intercept, okay, and I'm going to write this over here. Our x-intercept is when y equals 0. Okay, and we're going to go ahead and do that, substitute that in and solve for x, and that should give us our answer. So I'm going to substitute 0 in for y, and I'm going to rewrite my equation, plus, and I'm going to rewrite this as 1,500 over 9. And we could almost simplify that and rewrite this as negative 2/3 x plus 500 thirds. Okay, we can divide each of these numbers by 3. All right, so then we can go ahead and solve this. And so what we end up getting, I'm going to go ahead and solve this for x. I'm going to just add 2/3 x to both sides. And so as a result, I'm going to get 2/3 x is equal to 500 thirds. Okay, now in order to solve this for x, okay, what I can do, since I'm multiplying by a fraction, I could just multiply by its reciprocal to move that number to the other side. Okay, and so what we end up getting is we get 2 and 2 divide out, 3 and 3 divide out, so you're just left with x. And then this is equal to, okay, the 3's divide out. So now we're just answering the question, what's 500 divided by 2, which is going to give us 250. Okay, so that's our x-intercept. So this is our x-intercept. All right, so I'm going to come back over here, and I'm going to say the one that lands at 250 is this one. Okay, 250, and this was 166.6 repeating. So this is the graph that represents the situation. Okay, now it says that, and we kind of answered this question. So suppose on this day, all tickets were on sale for the child price of $6. How many tickets were sold? So if 0, that means that 0 adult tickets sold, okay, 0 adult tickets, that means that y was equal to 0, okay, because that was the number of adult tickets. So the answer to that question, if you had 0 adult tickets sold, what is the x value on that graph? And the value is 250. So how many tickets were sold? And we can say 250 tickets. Okay? All right. Let's take a look at the next problem. It says, write a linear function to model the following situation. So an airplane is 30,000 feet in the air and descending 1,000 feet for each mile it travels, okay? So I like to draw a picture in this type of situation. I'm going to draw a graph, okay, an x and y graph, and I'm going to say that the y-axis is height, and that's in feet, okay, and we'll call this 30,000. So let me write that this is 30,000 feet, okay, and here's your airplane, and then we'll call this x-axis distance in miles. So distance, and that's in miles. So for every mile that you travel, okay, we drop down 1,000 feet, and we get this linear relationship here, okay. So this would be, 29,000 feet at this value here, 29,000 feet. Okay, so here's the thing, is that, we know that we're descending, okay, so we know that our slope is going down, and we have an initial value. We have a y-intercept of 30,000. So if we wanted to model this, first of all, we need to say that x is equal to miles, and y is equal to the height, okay, your altitude, okay. So if we wanted to write this out, we know that for every mile that we travel, we drop down 1,000. So we get this rise over run. We get this little triangle here, so that for every 1 mile, we drop down 1,000 feet, okay. So our slope here, m, is equal to negative 1,000 feet per mile, okay, feet per mile. And that's that's kind of said here, 1,000 feet for each mile. All right, and so that's just something that we need to read. When you see this this idea here of a rate, okay, that's what your slope is. All right, so let's go ahead and let's write this out, and let's just say that y is equal to negative 1,000x plus 30,000. Okay, and that's the value. That's an equation that represents that situation. Okay. All right, next one, it says the equation y minus 53.75 is equal to 3.25 times x minus 15 represents a linear relationship between the cost of an order of widgets and the number of widgets ordered. Now, here's what it says, okay, a relationship between, okay, the cost of an order and the number of widgets ordered, okay? So what we know is that x is equal to the number of widgets ordered and y is equal to the cost of an order, okay? So, so here's what we know. That's what we know. All right. Now we're also given this equation in point-slope form. So I know that x, okay, in this scenario, x is equal to 15, okay, and y is equal to 53.75, okay. So, and then we also know that our slope, okay, our slope, m, is equal to 3.25, okay? And so, so what I can tell from this is that if 15 widgets are ordered, okay, if 15 number of widgets are ordered, then we know the cost is going to be $53.75, okay? So, and that's what it tells us, is that an order of 15 widgets costs $53.75. Okay, an order of widgets costs $53.75. But what we have to figure out is this rate. Okay, and ask the question, what does this mean? Okay, what does the rate represent? Okay, and so we have to say, you know, what does this mean? Okay, now this is a rate of change. Okay, this is a rate of change. Now, if I look at the context of the above, you know, options here, you know, it tells that a manufacturer sells widgets for $32.25 each. This is a rate, okay? And all the other ones, they say that they have a flat shipping rate of $3.25 on all orders, okay? And then, you know, same thing here, flat shipping rate on all orders. Now, the problem is that even though they use the word rate, you are charged a flat shipping rate. This means a one-time charge. Okay? And that's not what a rate of change is. A rate of change really is, you know, has something where you pay a certain amount for every widget that is sold or whatever, or that's ordered. Okay, so that's a really tricky question. This is the answer. Okay, because it does tell us, you know, that an order of 15 widgets, so the number of widgets ordered, costs $53.75. Okay, but the thing that distinguishes this one, or from these two, is that they have this flat shipping rate. Okay, a flat shipping rate is a one-time charge. Okay, a rate of change is something that happens over a period of time. There's more than one charge usually. So hopefully this makes sense. If not, come talk to me, but we'll see you soon. Thanks, bye.